Today I can say that I have a gift for you. I'm going to discuss a nice question selected from one of the most competitive university entrance exams in the entire world. This question says I sub k is equal to integral e raised to the power t divided by t raised to the power k dt, where t is greater than 0 and k is a positive integer. We need to show that k minus 1 times I sub k minus I sub k minus 1 plus e raised to the t divided by t raised to the k minus 1 is going to be equal to c, where c is a constant. Alright, after that we need to evaluate another nice integral. Integration e to the x times 1 minus x over 1 plus x, everything raised to the second power dx, where x is greater than negative 1. Alright, if your integration skills are good, I would like to recommend that you pause the video at this point, try this question yourself and see if you can get the answer. You can always come back and watch the rest of the video for the complete solution. Alright, at this point I'm going to start the discussion of the complete solution. Let me write down the given I sub k. I sub k is given as integration e raised to the power t divided by t raised to the power k dt. As soon as we see what we have to show, it's very intuitive that we need to apply integrations by parts. Therefore, I'm going to write down this same integral as t raised to the negative k times e raised to the t dt. That way I can identify two terms, one as du, the other one as v. When we label the left hand side as integration v du, the right hand side will be u times v minus integral u dv. Alright, now I'm going to apply integrations by parts and simplify I sub k further. Then our I sub k will be equal to, we have du being equal to t raised to the negative k. In order to obtain u, I need to integrate t raised to the negative k. If I do so, I get t raised to the negative k plus 1 divided by negative k plus 1. v is equal to e raised to the t and then minus integral u times dv. Once again, du is equal to t raised to the negative k. Therefore, u will be equal to t raised to the negative k plus 1 divided by negative k plus 1. Since negative k plus 1 is a constant, I'm going to write it outside of the integral sign as 1 over negative k plus 1. That times v equals e to the t. I need dv. I need to differentiate e to the t. When I do so, it will become just e to the t dt. Alright, now I'm going to do a modification. I can see that this term is negative k plus 1. In the given equation to be shown, I have it as k minus 1. Therefore, what I'm going to do is, I'm going to factor out a negative 1 from both of these terms. If I factor out negative 1 from those two terms, I get negative 1 times k minus 1. Alright, let's do that. Now I sub k is going to be equal to, I will write down that numerator as it is, t raised to the negative k plus 1 times e to the t. From the bottom, I'm going to factor out a negative 1. That negative 1 I will just write as a negative symbol on top. And then in the bottom I will have k minus 1. In the next integral, right here I have a negative symbol. When I factor out another negative 1 from the denominator, that negative symbol will become a positive symbol. And then I have 1 over k minus 1 integral t raised to the negative k plus 1 times e to the t dt. Alright, next I'm going to multiply both sides by the common denominator on the right hand side, which is k minus 1. When I multiply both sides by k minus 1, on the left hand side I will have k minus 1 times I sub k On the right hand side, I will just have a minus t raised to the negative k plus 1 times e to the t plus integral t raised to the negative k plus 1 times e to the t dt. Alright, what's next? Now I'm going to once again look at the given equation to be shown. In the given equation to be shown, I have t raised to the k minus 1 in the denominator rather than t raised to the negative k plus 1 on the numerator. What I currently have is t raised to the negative k plus 1 on the numerator in these two places. So I'm going to rewrite that as t raised to the k minus 1 in the denominator. Therefore, this equation now becomes k minus 1 times I sub k equals negative e to the t divided by t raised to the k minus 1 plus the next one integral e to the t divided by t raised to the k minus 1 dt. Alright, now what I'm going to do next is I need to identify this term right here. If you look at the definition of I sub k, it was defined as I sub k equals integral e to the t divided by t raised to the k dt. According to that definition, this integral right here should be I sub k minus 1. Alright, now I can subtract I sub k minus 1 from both sides. Then this integral equation becomes k minus 1 times I sub k minus I sub k minus 1 is equal to negative e to the t over t raised to the k minus 1. Now I can add this term to both sides. Then it becomes k minus 1 times I sub k minus I sub k minus 1 plus e raised to the t over t raised to the k minus 1 equals 0. However, remember that when we apply integrations by parts, in order to obtain this term right here, the very first term, we integrated t raised to the negative kth power. When we integrate something, we always get an arbitrary constant. So even though this original integrations by parts formula doesn't have a plus c, we need to add a c, an arbitrary constant, with each iteration of integrations by parts. Therefore, I'm going to go ahead and add a plus c to each of these steps. On this right hand side, I'm going to have that plus c. I will add the plus c here as well. For each of these steps, I'm going to add a plus c. Therefore, here also I will have a plus c. And here also I will have a plus c. Alright, now I'm going to go ahead and erase 0 plus c and write it as all equals c. Now that's what I need to prove. Proof completed. But we have one more thing to do. That is, we need to integrate e to the x times 1 minus x over 1 plus x, everything raised to the second power dx. To integrate this function, what I'm going to do next is I'm going to rewrite this one as integration e to the x within parentheses 1 minus x. That term I'm going to write as 2 minus 1 plus x. In the bottom I have 1 plus x, everything raised to the second power dx. Alright, and then I'm going to expand this numerator using a minus b raised to the second power. We know a minus b raised to the second power is equal to a squared minus 2ab plus b squared. We can use that expansion and expand 2 minus 1 plus x, everything raised to the second power, by taking a equals 2 and b equals 1 plus x. Alright, now this integral becomes integration e to the x. On the numerator, I will have 2 raised to the second power, which is 4, minus 2 times 2 times 1 plus x, which is 4 times 1 plus x, plus 1 plus x raised to the second power. In the bottom, I will have 1 plus x raised to the second power and dx. What I'm going to do next is I'm going to split this integral into 3 integrals as 4 over 1 plus x squared, 4 times 1 plus x over 1 plus x squared, and 1 plus x squared over 1 plus x squared. Then this integral becomes equal. The first term is integration e to the x times 4. That 4 I will write outside. Inside integration, I have e to the x. In the bottom, I have 1 plus x squared dx. That's the first part. The next one also has a 4 and it's minus. I will write down that minus 4 outside. Integration e to the x 1 plus x over 1 plus x squared. One of those factors will be simplified and we can write it as e to the x divided by 1 plus x dx. And then the last term is plus integration e to the x 1 plus x squared divided by 1 plus x squared. Those two second order factors will be cancelled and it becomes just e to the x dx. Alright, we can quite easily integrate e to the x dx. However, these two terms should be integrated and they look like somewhat challenging. In order to integrate these things, we will see if we can use the result that we established earlier. In that, we had an I sub k. I sub k was equal to integration e raised to the t divided by t raised to the k dt. We need to see that this integral was labeled as I sub k. That is because t is raised to the kth power. In addition to that, what we have to observe is e raised to the power is t, and that same power is the base in the denominator. Alright, if we can see those two characteristics, then we can actually write down these given integrals, these two integrals basically, in terms of I sub k. Alright, in order to do that, the very first thing is I need to have this e raised to the exponent to be exactly the same as the base in the denominator, which is 1 plus x. How do we do that? We can easily multiply both top and bottom by e. I multiply by e and divide that out by e. When we do that, these two terms, e to the x and e, will be simplified as e to the x plus 1. So I'm going to go ahead and simply erase this e right here and write down plus 1 right here. And I can do the same modification for this second term as well. I'm going to write a plus 1 right here and divide that out by e. Now pay attention to this integration. That integration has e raised to the x plus 1. Therefore, you can see it like t is equal to x plus 1. And what is the k? K is equal to 2. That is the exponent in the denominator function. So k is equal to 2. With that identification, that first integral can be written as 4 divided by e times I sub 2. Similarly, the next integral can be written as minus 4 divided by e. For that also, you can see t is equal to x plus 1 and k is equal to 1. Therefore, that term is equal to I sub 1. And then we have plus integration e raised to the x. We know integration of e raised to the x is equal to e to the x. Alright, now we can do some nice things. From this first part, I can factor out 4 divided by e. If I do so, I have 4 divided by e times I sub 2 minus I sub 1. Outside, I have e raised to the x. Now, is there a way that we can find I sub 2 minus I sub 1? We can use the result that we previously proved. The result that we proved was k minus 1 times I sub k minus I sub k minus 1 plus e raised to the t divided by t raised to the k minus 1 is equal to a constant c. Remember, we used t as x plus 1. Alright. Now, if I replace k equals 2 in this equation, I get k minus 1, 2 minus 1, which is equal to 1, times I sub k, k is equal to 2, minus I sub k minus 1. Since k is equal to 2, that's going to be I sub 2 minus 1, which is I sub 1, plus e raised to the t. Remember, t is equal to x plus 1 for this example. E raised to the x plus 1 divided by t once again, which is equal to x plus 1 raised to the k minus first power. Since k is equal to 2, k minus 1 is equal to 1. All that's equal to c. And what we need is to subject I2 minus I1. I2 minus I1 is going to be equal to c minus e raised to the x plus 1 over x plus 1. Alright, now we can substitute all of these right here and obtain our final answer. Therefore, our final answer is going to be equal to 4 over e, within brackets we are going to write down c minus e raised to the x plus 1 over x plus 1, close brackets, and then I have a plus e raised to the x. Of course, this can be simplified some more. We can distribute 4 over e to each of these two terms. When we do that, the first term becomes 4c over e minus 4 over e times e raised to the x plus 1 over x plus 1 plus e raised to the x. What we need to see is that this first term right here is a constant. We can write it down just as some constant k. This term right here can be simplified more. I can cancel out one of the e terms on the numerator with the e term in the denominator. Therefore, that term becomes minus 4 e raised to the x over x plus 1. And outside, I have another e to the x. Alright, so this is our final answer. This is our final answer for the integration e to the x times 1 minus x divided by 1 plus x, everything raised to the second power dx. We showed that this is equal to k minus 4 e to the x over x plus 1 plus e to the x. I hope you enjoyed this example. Thank you so much.